Hello everyone and welcome back to another video. I'm going to be doing another LeetCode problem today. It's again on array, easy problem. So today we're doing number 35, which is search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. So, and I must write an algorithm with O of log n runtime complexity. But I'm actually gonna first do a more simple approach, which is linear search. And with linear search, it's you're just going down the list one by one basically, to see if it's like the target or not. And if it's not, we'll just return the num's length. So, and then later on, I'll do the O of log n runtime. For now, let's do the linear search, which is for int I equals 0. I is less than nums.length I plus plus. So it's gonna go down the array. And then we write the if statement. If nums I is greater or equal to target. And then we just return I, which is the index. Okay? If the number is less than the target, we'll just continue. So there's nothing to do there. And then if there's afterward, we just need to return nums.length. So this part, it's if target is larger than all elements in the array. And then all you got to do is insert it at the end. For this part, it will basically like return the index where like the target should be inserted. So it's if you find the number, or the target is that number, or if the target is slightly bigger, I'll give an example. So let's go through like example 1, which is so 1, 3, 5, and 6, and our target is 5. So you see it sees 1, and the target is 5. 5 is greater than 1, so this if statement would be false. So it continues. Same with 3, it's false, it will continue. But with 5, it's equal to target, so it will return I, which is 2. Yep, an index of 2. And then with example 2, if target being 2, it is greater than 1, so condition is false. But afterward, it is 3 is actually greater than the target, which is 2, so it will return I, which is 1 at this position. So this is where it should be inserted. And then with number 7, so if target is 7, it's same thing, but this time it's even greater than 6, and that ends the array. And it's just gonna return, because everything is basically continued, it will just return this num's length. Since the target is larger than all the element, it's inserted at the very end. With this, oh, I forgot. Muscle memory, whatever. Yep. So although this code works, you do gotta know that this is a lot slower. Right now, even though the runtime says 0, that's because the array is like really small. If the array was to say like up to 1,000 or 10,000 amount of numbers, it's gonna take a very long time to go through each one of the numbers, right? In the worst case, if the target ended up being larger than every of the element inside of the array, the computer is still gonna go through every single one of them to try to go through it. So this works, it's just not ideal. So let me delete this real quick. And you also got to know that this only works if the array is sorted. If it's not sorted, then I mean you can just do the array dot sort, but still. That's just gonna like add in like more time into, just because you have to first sort each of the numbers out, and then afterward then you like go through the list and like search for the target. But now let's try to do the log of n, which the approach we're gonna go for is the binary search. Now I don't think I should probably make a video on explaining how binary search works, but for now, if you don't understand, that's fine, because I did just make the linear search, which also works. It's just not like ideal, but let's go with the binary search approach, which first we're gonna make a left equals 0, and then we're gonna make a right, which equals nums.length minus 1, and then while left is less than or equal to right, we're gonna have a mid that equals left plus right, left plus right minus left divided by 2. So this one would be the middle index. And then if nums mid is equal to the target, then we just need to return mid, meaning target is found in the target found. Else if nums mid is less than target, then left equals mid plus 1. Am I missing something? Looks very interesting. I think it should be fine, yeah. Then else right equals mid minus 1. Let's put the searches in the right half. Ooh. And then this search in the left half. And then if you return, and then this basically return the index where target should be inserted. Perfect. Okay, so with it's slightly difficult to explain just by like looking at this. Like I said, I'll try to make a video on how binary search works, and I'll try to draw it out instead, because it's a lot easier to explain while drawing it out. But if you want the answer for this, I get like, just by looking at this, you'd be like, okay, this looks a lot more of a code, like the line is longer than the linear search, but this is a lot easier because you're cutting the work down in half. That's why we have the middle, because we're cutting down the work in half each time. So again, if the array is like 1,000 or 10,000 or whatever, you're cutting everything down in half, because rather than going down each one, you cut the 10,000 element into 5,000, and then you keep doing it until you basically get the number. And that's a lot faster compared to counting it 1, 2, 3, 4 all the way to 10,000, So that's pretty much how binary search works. I guess for now I can sort of like give it a little bit of like a example walkthrough. So let's say if we take again this input, for example, and our target is 5. So the binary search step would be left starts off as 0, and then right is let's put equal sign. Left is 0 right here. Oh, I forgot about that. Okay, so left is 0, right is num's length minus 1, which is 4 minus 1. So right equals 3. And okay, so yep, while left is indeed less than right now. Let's put an equal sign as well here. We're gonna have a middle, which is left plus right minus left divided by 2. So right minus left equals 3 minus 0 divided by 2, which is just 1, and plus left, which is 0. So mid is 1. Keep in mind, encoding when like I didn't count like 1.5. I just count 1, ignoring the remainder. So mid is 1. If mid equals target, return mid. Mid is not equal to... Mid is right here. 0, 1, 2, 3. Yeah. So num's mid, which is, you put 1 here. 3 is not equal to target. So we ignore this. Is it less than the target? It is indeed less than the target. So left equals mid plus 1. Left equals 2. And then we go back. Now is left still less than right? And it is. So we go back and redo everything. This time it will be right minus left equals 1. 1 divided by 2 equals 0, basically, because again, ignoring the decimal or remainder. So what is it? Oh yeah, so it'll be 0 plus left, which is 2. So mid equals 2. So now we're here, basically, because num's mid, which is num's 2, index 2, does that equal to the target? And it does. So all we got to do is now return mid, which is 2. So the output should be that. I mean, yeah, I already know. But again, let's try another one, actually, just in case. Let's go with example 3, which is 7. So with the code, once again, we do the same thing. Left equals 0. Left equals 0. Right equals 3. And then mid equals, 1. Yeah. So obviously, we're doing this. Num1, is it equal to target? 3 is not equal to target. Is it less than target? It is. So we move it to the left. So left would be mid plus 1. So this becomes 2. We go back to the while condition. That is still true. And then left, 3 minus 1, 0 plus 2. So this becomes 2. Is this equal to the target? It does not. So we do it again. Go to the else if. Let's see. This is also, this 5 also less than the target. We do it one more time. Left equals mid plus 1. So this becomes 3. Is this equal to right? It is. So it's still true. Let's see. And then mid, okay, so mid equals 0, 0 plus 3. So mid equals 3. Is this 3 equal to the target? It is not. Is it less than the target? It is. So left equals mid plus 1 again. So mid being 3 plus 1 equals 4. Now that this while condition is false, because left is greater than 3. Left is greater than right, which is 4 is greater than 3. So this is false, and all we got to do is return left, which is return 4. So if case 3, return 4. Oh, I forgot to delete this. Now I'm going to have error. All right, there we go. Test result. Yes, sir. That's what I'm talking about. Now I just got submit. Yes, sir. That's what I'm talking about. Okay. But yeah, that's pretty much it. Thank you guys for watching. See ya.